Hey everyone, welcome to Chapter 3 of Section 1 of the Predictive Interaction Design course. Today we're going to be talking more about silent next state. So, in the previous chapter, we said that when a next state is requested, does the system have to load, initialize, or perform certain actions that could be done before the state was requested if there was a high degree of certainty that this would happen? And then we went over intermediary states. So these are system states where processes or components run after a prediction of an interaction is made, but before the interaction itself. This can take the form of an intermediary next state, silent next state, or light sleep. Now in this chapter, we're going to be talking more about silent next state, but we will talk about the other two further through this course. So what is silent next state? Well, silent next state is when a prediction event triggers certain parts of a system to prepare for a potential request or interaction. Now, all of these processes are quietly carried out without the user's awareness, and the term silent is used because the user isn't notified about any of these preparatory changes. Now, this is really good because if we predict that a user is going to interact with the system and then we enter silent next state, but then the user actually doesn't interact with the system, well, the user has no idea that any changes in the system happened at all, so they won't have any form of unease with the system doing something without their direct request. Now, I've got some examples of some intermediary states here. Now, what we'll do is we'll go through these examples together and we'll go through which ones are silent next state and which ones are intermediary next states, because there are some nuanced differences. But in all of these examples, the system does preload certain components and processes in anticipation of a user interaction. So let's go from left to right. So in the first example, we've got the TV. So the intermediary state on the TV would be that the internal components turn on and initialize, but the screen and speakers remain off. So the user will have had absolutely no indication that any change to the system here has happened. Thus, this would be a silent next state. In the next example, we've got a website. So within the website itself, links that we predict that the user is about to click on are loaded in the background, but the next page doesn't appear yet. So the user, if they don't click the link, has no idea that any change has happened in the system and they would be none the wiser. Now this, again, is a silent next state. The user has absolutely no indication that anything in the system has changed. In the third example, we've got a coffee machine. So the beans are ground and the water is heated, thus meaning that when the user requests coffee in their mug, the process will be much quicker, but the coffee's not brewed yet. Now, the user might actually hear that something's happening in the coffee machine. They would hear the grinder whirring away and the hissing sound of the water being heated. But again, remember, we're not giving them the result of their command, but they might perceive that some changes have been made. Now, this is an intermediary next state, where we prepare for the user command, but we can't actually do that in a manner that won't be sensed by the user. In the fourth example, we've got an automatic vehicle. So the transmission downshifts one gear in preparation for acceleration, but very importantly, the vehicle does not accelerate yet. Now, again, this is an intermediary next state. The user would sense, they would be aware that the system has downshifted a gear, but they still aren't given the result of their command. In the final example here, we have a smart speaker. So this is a ALEXA, I won't say the names to trigger anyone's speakers, or a Google Nest, or a Apple HomePod, for example. So in this situation, if the speaker predicts that a user is going to ask it something, it can establish a connection with the server and prepare for audio upload and run all of the processes in preparation for an interaction. But most importantly, the speaker does not respond or ask for a command or have any indication to the user that system changes have been made. This, again, is silent next state. Now here we've got something called the state change breakdown map. Now this is a tool that you can use to actually break down the low-level components or processes that run after an interaction in your system and define silent next state for your system. So what we'll do is we can fill this out given that first TV example. And the way we use this is we look at the very left and we have the state change component column. And what we do is we write down all of the individual components or processes that run when an interaction is made. And then after we do that, we tick which ones are perceptible and which ones are non-perceptible. Then we transpose that over to the right side of the state change breakdown map. And then we list all of the components in which we tick non-perceptible on the left column of that, and all of the perceptible components on the right column of that. And then effectively, we just have to look at the left column, and that is your silent next state. So if we have a look at the TV example, what we've done here is we have written down all of our state change components. So we've said internal hardware systems load and initialize, Wi-Fi connection is established, the display turns on and the speakers turn on. You can go as low level or as high level as you want in these maps, as long as it's appropriate for your system design. And all we've done is we've ticked which ones then are non-perceptible and which ones are perceptible. So internal hardware systems loading and initializing is not perceptible. The system establishing a Wi-Fi connection is not perceptible, but the display and the speakers turning on are both perceptible. And then all we do is we just look at what we ticked with non-perceptible, and we transpose that over to the right section on that left column under non-perceptible, and we do the same with the perceptible. And then what we have under that silent next state column there, under non-perceptible, is the processes of our system that can run when a prediction's made that the user is going to interact with the system. So it's a super handy tool, very simple to use, and you can get as low level as you'd like, depending on the appropriate nature of your system design here. And what we've done there is we have decided that when a TV predicts when a user is going to interact with it, the internal hardware systems can load and initialize, and the Wi-Fi connection can be established, but we will only wait for the actual interaction itself for the display or the speakers to turn on. Otherwise, if the TV just turned on when it thought that the user was going to interact with it and the user had no intention to interact with it, well, they would be quite annoyed and also maybe a little bit creeped out as well. We kind of enter that uncanny valley territory there, and that is one of the golden rules of predictive interaction design, but we will talk a little bit more about those later on in the course. So that is intermediary states and silent next states. In the next chapter, we're going to be looking at mapping out the user journey before they make an interaction with the system, and how to measure and choose when to make the prediction to enter our intermediary state. I'll see you there.